example, we consider a collision between two carts, and the carts are actually traveling in opposite directions initially, and after the collision, they both take off in different directions. So I have a 2 kilogram cart that's green, and it's traveling to the right with a speed of 2 meters per second, so it has a positive velocity. And it collides with another cart that has a mass of 1 kilogram, the yellow cart, and that cart has a velocity, it's traveling to the left with a speed of 6 meters per second. And because it's traveling to the left, its velocity is negative because we're considering the right to be the positive direction. After the carts collide, the green cart, the 2 kilogram cart, is traveling to the left with a speed of 3 meters per second, and because it is traveling to the left, it has a negative velocity, so the green velocity final is -3. And we want to determine what is the velocity of the 1 kilogram yellow cart after the collision. And so there's no friction involved in this question, it doesn't mention friction, and so we can assume that momentum is conserved. And so if momentum is conserved, that means the total momentum of the system, meaning both carts, before the collision has to equal the total momentum after the collision. The total initial momentum would be the momentum of the green cart plus the momentum of the yellow cart, and that would have to equal the final momentum of the green cart plus the final momentum of the yellow cart. And so we can use this information to solve for the final velocity because we know momentum is mass times velocity. And for each of these cases, we have the mass and the velocity of each of these carts, except for the yellow cart. We don't know the final velocity. So if we can solve for the initial momentum of the green cart and the yellow cart and the final momentum of the green cart, we can use that to determine the final momentum of the yellow cart. And then once we know that final momentum, we can use that information along with the mass to figure out what the velocity of the yellow cart is. So the best approach for this is to look at it in steps. And so we can start by determining the initial momentum of the green cart. And the momentum is the mass times the velocity. So we take the mass of the green cart, 2, times the velocity of the green cart, 2, and we get 4 kilograms meters per second. We can also determine the initial momentum of the yellow cart, and that's the mass of the yellow cart, which is 1, times the velocity of the yellow cart, which is -6, and we get a -6 kilograms meters per second. The total initial momentum of the system is just the addition of these two momentums of the two carts, the green cart and the yellow cart initially. So that's 4 plus a -6, which gives me a -2 kilograms meters per second. So the total initial momentum of the system is negative in this case because the yellow cart actually has more momentum than the green cart and it's traveling to the left. Since momentum is conserved, we know that the total final momentum of the system has to equal the total initial momentum of the system. So we know the final momentum of the system is a -2 kilograms meters per second. Now remember from the last slide, we know that whatever the total initial momentum is and the total final momentum are equal, and the total final momentum of this system has to be the momentum of the green cart plus the yellow cart. So our goal is to figure out what is the momentum of this yellow cart. So next step is to solve for what is the final momentum of the green cart. And that's just the mass times the velocity of the green cart after the collision. So the mass is 2 and the velocity is -3, so that gives me a -6 kilograms meters per second. So we know the momentum of the green cart initial, the yellow cart initial, and the green cart final. We can use the fact that momentum is conserved and we can solve for the final momentum of the yellow cart. So we know the total final momentum, which has to be equal to the initial, is -2. We know the final momentum of the green cart, we just found that, and we know that if we add that to the yellow, it has to equal the total final momentum. So the total final momentum of the system is -2 kilograms meters per second. We just solved for what the green cart's momentum was. It was -6, and that added together with the yellow cart's momentum has to equal a -2. If I add a +6 to both sides of this equation, I end up with the final momentum of the yellow cart as being 4 kilograms meters per second. So I know that this yellow cart here has a momentum of 4 kilograms meters per second. I also know that momentum is mass times velocity. So if I want to determine the final velocity of the yellow cart, if I know the momentum is 4, I know that the momentum has to be the mass of the cart, which is 1, times the final velocity, which we don't know. And so if 4 is equal to 1 times the final velocity, if I divide both sides here by 1, I would get that the final velocity of the yellow cart would be 4 meters per second.